Well, students, in today's lecture of RDDNS, we are going to learn a few more things about introduction. Okay, before we start today's lecture, let us just recall the things that we have studied in our last class. And this is our lecture 2. Okay, in the last class, we have seen what is your data. Okay, then what are the different types of data types we have, and what are the different types of data we have, like audio, video, and all these things, and what is your database. Okay, from there we have described what is your database system. From there we have also come to know about your database DBMS, okay, database management systems. Then what are the different abstract level of it, okay, conceptual view, logical, conceptual model, or higher model, logical model, and physical model. All those things we have seen. We have also discussed about schemas and instances of your database systems. Okay. In today's lecture, in continuation to our last class, in today's lecture we will again continue the introduction part only. Today we are going to explore a few more things about your database systems. Okay. So let's start with today's lecture. Now, the first and the foremost thing, the language that is being used in case of your database. Okay. Formally, if you see the language that is being used in your database system, there are basically two types. One is your data definition language, and another one is your data manipulation language. Okay. What is the data definition language and what is the data manipulation language? We are going to explore one by one. But students, truly speaking, there is both of these, data definition language and data manipulation language, belongs to a special kind of language, which is your structured query language. But this language have got different purposes. What we do different things in this different language. In data definition language, it has got a special purpose, and data manipulation language, it has got special purpose. But both the features are being provided by your structured query language. These things we are going to explore in our near future lectures. Okay, what is structured query language and how it is, how it works, and all those things. Let's start with the first and the foremost, that is your data definition language. Okay, we specify a database schema by a set of definition expressed by a special language called your data definition language. As we already discussed in the previous classes, that schema and instances. Okay. What is the schema? Schema is what nothing but your tables that, or the relation that we are going to describe. Okay, in that relation we are going to keep what are the attributes and how the things will be uh, designed. How we are going to design your database is being defined in case of your data definition language. Okay, in this data definition language, we mainly focus on data storage, how the data will be data stru- structure will be there, storage structure of your data will be there, and the access method. What are the different access methods that need to be used by the database system? Okay, that is going to be defined in case of your database definition language. Okay, and together the this data definition language, because it supports data structure, data storage. It defines the data storage structure, and also defining the systems. So it is also known as your data storage and definition language. Okay, but other the data definition language is all otherwise known as your data storage and definition language. Okay. Next, whenever we work on your data definition language, or you say the DDL, okay, it works impose certain constraints on the data, on the database. Okay, to maintain the consistency in the database. Okay, what is the need of the consistency? We are going to explore one by one. Okay, now there are different constraints that is being imposed by your database systems. Okay, it implements. Okay, but this constraint may be are of two types. One may be your integrity constraints, and maybe another one may be your arbitrary predicates. Okay, these arbitrary predicates are very difficult to analyze. Okay, so these are no more used right now, but currently this integrity constant is very popular, and under this integrity constraints we have got four different features over here. Okay, that is your domain constraints and referential integrity constraint, assertions, and authorization. Okay. We'll explain one by one about your domain constraints, referential integrity, assertions, and authorization. Okay. What exactly domain constraint is that? A domain constraint, what it does is that, first of all, let us note what is a domain. A domain is a unique set of values permitted for an attribute in a table. Okay, let's see a table. Okay. This is a table. Take for an example, this is a table. These are what we have the attributes. It is your ID, name, and your semesters. Okay, and this is your age. Now, in this table, what happens? We are going to impose your domain constant. What is the domain constants? The domain constant imposed, let's suppose say the name. A name will always consisting of some text. Okay, it should not be any number. So this is what is being imposed. Okay, whenever we talk about age, the age should always be consisting of integers number. It should not be consisting of text. Okay, this is a wrong interpretation. Now in ID should have also will always have an integer numbers like this. Like we can also impose the domain constant like the range of values. Okay, if you describe a month, like month of a year, it should be some of the values like January, February, December, and within the December. It should not take any other value, any other value except these values like January, February, and December. Okay, so this is what is being, it has to be imposed on the database. Otherwise, what happens? There will be a wrong interpretation of your database. If you see something a month. Okay, month is an attribute, and another attribute you insert a value like XYZ. Is it a valid one? It is not a valid one. If you describe a month, if the month should either be a Jan or February or any value right from your January to February. It should not be anything beside except these values. So this constant has to be imposed on this one. Okay. Now and another constant that we can impose on this one is that age cannot be a negative value, minus 70. Age cannot be a negative value, right? So this constant has to be constants has to be imposed on the database to correctly define or define your database. Okay, this is what your domain constant. Next, see what is your referential integrity constant. What is a referential integrity constant? Is that, now let's suppose say see this is an example. Okay, this is a table 1. Okay, and this is table let's suppose 2. This table 2, if you just observe this D number, we have an attribute D number here and we have an attribute D number. Okay, so this table 1 has been derived from this table 2. Okay, now in this table 2 we have attribute values. These are what we say, we have the attribute values. Okay, this value if any table derived or refer this table with this attribute, then they should possess the attribute values of this kind, except this is should not have any other value or null. Either null is accepted or any of the value present within this column. Okay, now you see this table 1 has referred this table 2 with respect to your D number. So this D number is a primary key for this table, and this D number is a foreign key. This all foreign key and primary key we are going to learn in our future classes. But remember students, if any table is derived from a particular or referred with respect to a particular table, then they will be referring to some attributes. They'll be having a common attributes among them, and with that attribute they will be referred. Okay, and these attributes may be referred in one table as a primary key and in other table as a foreign key. Okay, now the permitted value for this attribute is 11, 24, and 13. But if you see here in this table, except this 11, 24, and 13, we have an unknown value that is your 18, which is not permitted. So this constant has to be particularly mentioned, or it has to be imposed on the database so that the rules and regulations should not be violated. Okay, this is one of the integrity that we need to have in your database system. Next, we have assertions. Okay, what is an assertion? That what is this integrity says? What is this? What is this constant says? Okay. This is there are certain things that you cannot impose using your domain constraint or referential domain integrity constraint or referential integrity. Okay, so that what that thing has there are the things that we cannot do with the domain or referential integrity. We have assertions, and that helps us to impose some certain constraint on the database. Okay, now let's take an example. In a if you define a attributes, let's suppose a department. Okay, in this department, let's suppose we have different courses. Okay, so if the department is having certain courses, it should not exceed 5 courses in a semester. Okay, so this has to be imposed. In addition to the department, we have to restrict the number of departments course in the number of courses in the department to only 5, not more than that. So this kind of constant is what we say your assertion constraints, and this thing we will explore in our future lecture when we deal with your structured query languages. Okay. Next we have authorization. This is very important. So if we give an authorization to any user, then what are the things that any user can do? So we can differentiate the user based on this authorization. Okay. So what are the authorization that we can give to the users? Maybe it may be read authorization. What this read authorization does is that either it allows only to read the content of the database, nothing more than what no modification can be done. Now, if we impose insert authorization to an user, then the user can insert new data to it, and but it cannot modify the existing data. Okay. Now, if its updation authorization is given to an user, you can modify it, but it cannot delete the data. And if delete authorization is given to an user, it allows deletion of the data. So we may assign the users all or non combination of this. So a user can be accessed, or a user can be given any of these, one of these authorization, or combination of this authorization, or none of this. So it depends upon the database administrator that he is going to give the authorization to a particular user. Okay. Now, whenever we define a database defined language, any database we design with the database defined language, then with the implementation of a data definition language, what we are going to get is that we are going to get a data dictionary. Okay, which which contains what is your metadata, that is data about data. So the output of your data is nothing. Data definition language is nothing but a schema. Okay, and that schema will be having certain attributes and certain things that we are going to do. Okay. Next, we have another important language, that is your data manipulation language. Data manipulation language that enables user to access or manipulate the data. Okay. Then, whenever we talk about the manipulation of your data in a data model, this manipulation refers to these following features. Okay. What a user can do? A user can perform retrieval of information stored in the database, insertion of new information into the database, deletion of information from the database, and modification of information in the database. Okay, so the data manipulation language supports these features. Okay, and if we just analyze the data manipulation language, this data manipulation language are of two types. Okay, it may be a procedure oriented or a non-procedure oriented. Okay, procedure oriented is very specific. Why it is no? We need to define each and everything clearly, prominently in that language. Okay, whenever requires a user to specify what data are needed and how to get access those data, and all this thing has to be prominent. It's very tedious. Okay, but in case of your declarative language, which is also called your non-procedural language, where SQL is also a non-procedural language, requires users to specify what data are needed without specifying. Here, how you are going to do it need to mention in case of your procedural language, where it is not required in case of your non-procedural language. Okay, this is what happens with the declarative data manipulation language. And in this declarative data manipulation language or data manipulation language, we have a special thing that is called your query. By using this query, what happens? But before that, we need to know what is a query. A query is a statement requesting the retrieval of information. Okay, and this The portion of the DML that involves information retrieval is called your query language. Okay, and this is a part of your database data manipulation language. Okay, and next we are going to see what exactly your relational database. A relational database is nothing but it is derived from your relational model. Okay, and normally this relational database is represented using the tables. Okay, and inside your table we have rows and columns associated with this one, and these columns are nothing but your attributes, and these attributes will have some values. Okay, and this relational database also includes your data manipulation language and data definition language. Okay, and before that, a relational database is based on the relation model. As you have already seen some of the database model, one is your ER model, relational model, okay, object oriented model, and all those things, network model, and all everything. Among those models, this relational database is described based on a relational model. Okay, and this is a small example where we have a relational database where it consisting of a table, rows and columns. These columns are nothing but your attributes, and each and attributes will have certain values. Then, what is the role of your data manipulation language and data definition languages? That is a small example of data definition language where we are going to create a relational table or a database. Okay, this is a command of SQL. This is based on the structural language that supports your data definition language, where you are going to create a table of data and department with certain attributes, and what is the data value associated with this one we are going to see over here. This, after executing this command, what we are going to see is that we are going to create a table called your department with having certain attributes like department name, buildings, and that's it. Okay, now once the table is created, then we can manipulate the table. Okay, by using data manipulation language. That is, this command of your SQL is going to insert, select a particular thing from your from the table Okay, so this is how exactly your things is done in case of your database relational database. Okay, and this database languages help us to either create or manipulate the things inside your database, okay, or relational database. Okay, now the next we have to see what is your database access from application program. Okay, now because your data base languages with DDL or DML, it has certain drawbacks. Drawbacks means this DDL or DML, both of them are known as your SQL, part of your SQL. The SQL does not support actions as an input from the user or output to be displayed on the system. At the same time, it also doesn't support communication over a network. Okay, so moving of things from inside a network, how the thing data will be moving, it is not being supported in case of SQL. To support this facility, what we have, we need to take the help of your application programs. There are so many application programs available in the market. Some of them are your C, C++, Java, or Python, to name a few. And they support what they support is that they support taking the user from the input, store it in the database, and also display it on the screen, also in all the communication over the network. Okay, such computation and actions must be written in host languages like your database with embedded queries and all these things. Yeah, so embedded queries and all these things is supported. The best thing is that you ODBC. Through this ODBC, what we are doing is that we support all these things. Okay, taking the input from the user, display it on the screen, and all these things. One of the features this interface provides the communication between your application program and the database. Okay. Now, what is an application program? Application programs are programs that are used to interact with the database in this system. Okay. So even if you use your SQL, there are certain drawbacks that cannot be, which through SQL we cannot perform it. Okay, so we need to use some application program to facilitate this one. Okay. Now, next thing is that how data is being stored inside your database, and the how what are the structure of your query and how this is being uh, queried inside your database, and how the information are being retrieved from the database. You are going to see it. So looking into this concept, the how the data storage, the data storage has been handled by your storage manager, and query processing, uh, or querying is also handled by some other person. Okay. Now, what is the responsibility of a storage manager? How the things are being done, performed for storage and querying? We are going to explore one by one. The first one is that storage manager, which deals with your data storage. We are going to see. The manager is responsible for storing the data, retrieving the data, updating the data in the database. So it supports three features. One, it supports stores the data, it also retrieves the data, and any updation that need to be done with the data through some manipulation and all this thing that need to be updated inside your database. Okay. So the basic components that is associated with your storage manager is your authorization and integrity manager. Now, authorization means whenever any user access a database, whether he's authorized or not, that is being also done over here. Okay, and we have an integrity manager that supports. There are certain constraints. Okay, that as I told you already told you that if you consider about the month and all this, whenever whatever the value that we insert inside your database, whether it's a valid one or not one, it has to be checked. So it is the responsibility of your storage manager to look after this. Okay? Then we have a transaction manager. Okay, this transaction manager, what it does is that it ensures that the database remains consistent, correct state, even if the failure occurs, or sometimes when we have a concrete transaction execution, multiple users perform the same kind of transaction, then there should not be any conflict occurs. So it's the responsibility of the transaction manager to take care of all these things. This is a part of your storage manager. Then we have a file manager, which manages all the allocation of space to your database, and that also takes care of your space on the disk storage and also data structure used inside your for the database. Okay. Now, there is a buffer manager. What is the need of a buffer manager? Now, whenever we want to fetch the data from the storage, secondary storage to the primary memory, it requires a buffer manager to take care of that. But whatever the things you memory allocation, right, from the main memory allocation, deciding what are the data to be cached in the memory, how much data has to be transferred, what is the where it need to be, how much is to be stored, and all those things is taken care of by your buffer manager. Okay, so these are some of the components of your data storage or storage manager of your database system. Okay. Now, to manage all this activity, the data storage manager uses certain data structures. Okay, it uses three data structures. That is your data files that stores the database itself, and we have a data dictionary. As I already told you that the output of your data definition language is a data dictionary. We store the metadata about it and certain indices. What is the indices? Why the requirement of indices? The indices helps to retrieve the data as fast as possible. So indexing and all these things that we will be explore few things that we will explore in our future classes. Next, we have a query processor. Okay. Now, what is the responsibility of a query processor? As we have already seen that query processor queries the database to retrieve the all desired information. Okay. So a query processor, the component of your query processor includes a DDL, data definition language interpreter. Okay. Then a DML compiler and a query evaluation engine. Okay. Now, what is the role of your data DDL interpreter? Is that which interprets the data, what is being defined in your database language, and records the definition in the data dictionary. This is being done by your query processor. Best, and a DML compiler which translates the DML statements in query language and into an evaluation plan consisting of low-level instructions. Okay, and for this we need to so for a particular data definition, whenever we submit any query to a database, it has got certain interpretation. Okay, so to optimize all these things, we have a query optimizer. Okay, that will explore many things. What exactly the interpretation of a particular thing that has to be known. Okay. Now we have a query evaluation engine which executes the low-level instruction and generated by your DML compiler. Okay, this provides an interaction with the hardware and the software kind of thing. Okay, this is what is the query processor, responsibility of a query processor inside your database database system. Okay, then we have the last one is that your transaction management. Okay, what is the role of your transaction management? There are so many operations that we need to perform in your database. Okay, a transaction is nothing but is a collection of operations that performs single logical function in a database application. Okay, and whenever we perform any sorts of transaction inside a database, we need to see that whether it's done perfectly or not. That updation and insertion and all these things are following certain constant or not, it need to be followed. And for this transaction management, we have certain components as that of your query processing components, and we have other components. Same way, we have transaction management component that ensures database remains in consistency, which is very very important. And even if there occurs a failure, power failure or operating failure, whatever it is. Okay. Now, next important thing that we have is your concurrency control manager that controls the interaction among the concurrent transactions that occur simultaneously to ensure that there is a consistency in the database. Okay. So this is all about your transaction management. And next we have what exactly the structure of a architecture of your database. Okay. In the first we have in this architecture we have four different parts. Okay. This part that deals with this part that deals with your user, and it is your we have a query processor, this one we have a storage manager, this one, and finally all these things will be stored inside a disk storage. Okay. We have four parts associated with this one. This needs to be a naive user. A user can be a naive user and can be an application program or sophisticated user or a database administrator. It depends upon the kind of users that they are going to use the database. Okay. So depending upon the user, they are going to interact with the database using some query. We will have some interface that supports and that provides interface that provides access to your database. Okay, so this is what your basic database architecture. Okay, next we are going to move the application. Okay, a database application can be of a two-tier architecture or it can be a three-tier architecture. Okay. In case of your two-tier architecture, the application resides in the client's machine. The application itself resides in client's machine, where it invokes the database system functionality at the server machine. There will be a server machine through which a client will be accessing the database by using its own applications and all those things. Okay, but this is different in case of your three-tier architecture. You can understand it in a better way. This is a two-tier architecture. This is a three-tier architecture, where the application remains within the client itself in case of two-tier architecture, and it accesses the database system using this network. But this is quite insecure. Okay, that there are certain vulnerability or threats may be associated with this one because the application is remaining the client itself. Okay, but in the three-tier architecture, what we have is the client will have only an interface with him, and it can but the application will be stored inside your application servers, and there will be a database. So a user will be accessing this database through the interface, but it has to pass through the application server. This is all mentioned over here. In case of a three-tier architecture, the client machine acts as a front end, simply a front end, not contains any direct database calls. The client end communicates with the application server through use of interfaces, and the application server in turn communicates with the database system to access the data required by the client. This is all about your basic application model of your database. Okay, but nowadays this three-tier architecture is completely followed. There are very few places where we use your two-tier architecture. Now, Now we have the users of your database. We have so many users, and these users have been defined with their responsibility. Uh, with their responsibility. Okay. Now we have users, database users, and we have administrators. Who are the users? Users may be a naive user who doesn't know anything about the database. He is going to use it. A user may be your application programmer. He is going to use it, and a user may be a sophisticated user or a specialized user who is going to use the database. Next, we have a database administrator, okay, who is uh, who is the main responsible person in the database systems, whose responsibility is to define the schema based on the client's requirement, storage structure of your database, and what are the access method, authorization, everything has to be done by your database administrator. Schema and physical organization or modification has to be done by your database administrator, and and also granting the authorization, which your user is going to do what kind of thing has to be also done by your database administrator. At the same time, once once in an interval, the database there should need to be a routine maintenance of your database once in a particular interval, maybe in a month, maybe in a week, or within a 20, depending upon the kind of application. The database uh, has to be maintained properly. Okay, so this is all about the basic responsibility of your database administrator. So with this, the basic introduction and overall view of your database systems, database management systems, we have discussed.